Neptune, a distant icy giant at the edge of our solar system, has been shrouded in mystery for decades. It is an immense dark vortex within its atmosphere, characterized by bizarre atmospheric phenomena and unexplained anomalies in its magnetic field. The spacecraft Voyager 2 embarked on an extraordinary journey through the solar system in August 1977, reaching Neptune in 1989. As it approached, it captured breathtaking footage that unveiled a majestic world shrouded in stirring bands of azure clouds. Neptune's true color is a softer, lighter shade of greenish blue, a subtle detail often overlooked in the grandeur of space exploration. When venturing online in search of more snapshots of Neptune, people notice a scarcity of images despite Voyager 2's impressive feat of flying within a hair's breadth of just 4,950 kilometers from Neptune's surface. The number of available photos remains surprisingly low. As Neptune resides 30 times farther from the Sun than Earth, this vast distance means that it receives only a fraction of the sunlight that our planet enjoys. Voyager 2's ingenuity knew no bounds. By deftly working its thrusters to swing past and employing extended exposure techniques, the spacecraft managed to capture and transmit back to Earth some of the closest and most mesmerizing images ever taken of Neptune. Just a couple of hours before zooming past Neptune, scientists got a close-up view of some interesting features high up in the planet's atmosphere, such as long, wispy clouds that resemble the cirrus clouds seen on Earth. These clouds are crafted from frozen methane, giving them a surreal appearance. Recent observations from the Hubble Space Telescope revealed that these clouds can form and disappear in the blink of an eye, showcasing the dynamic nature of Neptune's weather patterns. When the spacecraft flew by Neptune, it encountered a striking example of this event. The Great Dark Spot, a large oval-shaped cyclone resembling Jupiter's Great Red Spot. This immense weather system was roughly the size of the entire Earth. In conclusion, Neptune is a mysterious celestial body that has been shrouded in enigma for decades. Voyager 2's journey and observations have provided unprecedented views of the planet, revealing its unique features and the dynamic nature of its weather patterns. Neptune, an ice giant about 4 times wider than Earth, has an enormous volume of 15 trillion cubic meters and is 58 times larger in volume than Earth. The planet is mostly made of water, methane, and ammonia, with a thick atmosphere that extends deep into the planet, reaching down to a mantle made of methane and ammonia ice surrounding a rocky core. Scientists believe that Neptune might even have a superhot ocean hidden deep inside. Despite its icy name and outer appearance, Neptune's average atmospheric temperature is -360 degrees Fahrenheit, making it one of the chilliest places in the solar system. Most of Neptune cooled down between 2003 and 2018, though there was some warming near the South Pole from 2018 to 2020. The mystery of how an ocean might form inside this icy giant remains unsolved, but some theories suggest that internal heating caused by gravitational compression or interactions between Neptune and its largest moon, Triton, might play a role. Neptune stands out as the only planet that radiates nearly 3 times more energy than it absorbs from the Sun, possibly linked to its significant 28 degrees tilt on its axis. This tilt means Neptune experiences seasons much like Earth does, but with a twist. Each season on Neptune lasts around 40 years. Neptune's atmosphere is composed mostly of hydrogen, accounting for 80%, helium accounting for 18%, and a small fraction, about 1%, of other gases including methane. The striking blue color of Neptune is a result of methane clouds in the upper atmosphere, which absorb red light and reflect blue light. This coloration is enhanced by high-altitude clouds composed primarily of methane ice crystals, which scatter sunlight in a way that enhances the blue coloration. Neptune's dynamic atmosphere exhibits a multitude of features, including massive storms and powerful winds. On the other hand, Uranus presents a different aesthetic with its muted pale blue color due to its unique tilt, where its axis is nearly parallel to its orbital plane. Both planets contain trace amounts of other gases, including hydrogen, helium, and ammonia, along with the intricate interplay of temperature, pressure, and atmospheric dynamics, creating a complex and dynamic environment worthy of scientific exploration. The formation of a new storm on Neptune, reminiscent of a similar event detected nearly 3 decades earlier in 1989, remains mysterious to researchers despite years of study. These swirling storms, which take years to develop, suggest a complex and long-term process at work beneath Neptune's turbulent skies. The 2018 storm embarked on an unexpected journey, defying conventional expectations of planned planetary weather patterns. NASA researchers believe that a smaller vortex may play a pivotal role in the fragmentation of the larger storm, a phenomenon never witnessed before in Neptune's atmosphere. Neptune also boasts a fascinating feature: a system of rings. These rings were captured in stunning detail by the James Webb Space Telescope in 2022, revealing a spectacle unseen for over 3 decades since Voyager 2's last snapshot. The image unveiled not just Neptune's rings but also its accompanying satellites, painting a portrait of icy grandeur in the vastness of space. 5 distinct rings orbit Neptune, each bearing the name of a prominent astronomer whose contribution shaped our understanding of the distant planet. The closest and most diffuse ring, known as Hal, spans a staggering 26,000 miles with a radial width of 1 to 140 miles. Composed predominantly of dust particles, it shimmers faintly, embodying the ethereal beauty of the celestial realm. Next in line is the ring known as La, radiating a brighter glow but marred by a slight inconsistency in its measurements. Spanning a width of just over 62 miles, the Lassell ring steals the show with its expansive width of 2,485 miles, dwarfing its counterparts. Despite its grandeur, its dust content is relatively scant, hovering between 20 to 40%, lending it a pristine aura. The arcs of the rings are mysterious bright bands of dust circling the edge of the ring, each named freedom, brotherhood, courage, and equality. These arcs are dynamic, constantly exchanging material and changing in size. The reason behind the formation of these arcs remains a mystery, but researchers suggest that they might have formed due to the collapse of a parent companion or another object within the Roche limit, the distance within which a celestial body will disintegrate due to tidal forces exceeding its own gravitational forces. Triton, Neptune's largest moon, is unique because it orbits the planet in a direction opposite to Neptune's rotation. Triton is believed to be a captured Kuiper belt object, with geysers spewing nitrogen gas, creating a thin atmosphere and suggesting active geological processes. Triton's frigid demeanor ranks as the chilliest, geologically active entity across the solar system, with surface temperatures plunging to a bone-chilling -391 degrees Fahrenheit. Triton experiences tidal locking, meaning only one face perpetually faces its host planet. Triton defies the norm with its retrograde orbit, traveling in the opposite direction compared to its parent planet, Neptune. Scientists believe that Triton is from the Kuiper belt, a distant region filled with icy remnants from the early days of our solar system. As Triton hitched a ride with Neptune, it hit the brakes to avoid a head-on collision, settling into its peculiar orbit where its poles and equator take turns facing the Sun. Triton's journey could spell trouble for Neptune's other satellites, as Triton's trajectory might lead to cosmic collisions. Unlike Jupiter with its bustling entourage of moons, Triton's arrival shook things up, highlighting the stark contrast between the two gas giants. Around Neptune, Voyager 2 captured snapshots of Triton's surface in 1989, revealing a patchwork of frozen plains, towering cliffs, and mysterious dark streaks. What caught scientists' attention were the towering plumes erupting from its surface, hinting at unknown forces at play. Analyzing the craters dotting Triton's terrain, scientists uncovered clues about its tumultuous past. Some craters appeared remarkably fresh, suggesting recent impacts, while others showed signs of erosion, hinting at a dynamic surface reshaped by icy geysers and cryovolcanism. The most tantalizing discovery was beneath Triton's icy facade. Scientists suspect a hidden, possibly liquid ocean kept warm by tidal heating generated by Neptune's gravitational tugs. The eccentric orbit of Triton itself could harbor alien life, making it a prime target for future exploration. The plumes, towering jets of icy material spewing into space, suggest a subsurface reservoir of volatile compounds waiting to burst forth. Despite its frigid temperatures, Triton is a world of intriguing complexities deep beneath its icy surface, with a hidden reservoir of ammonia vital for the peculiar dynamics of Triton's subsurface ocean. The interplay of sunlight on Triton's surface further complicates its icy facade. When the distant rays of the sun penetrate Triton's thin atmosphere, they trigger a delicate dance of molecular compression. Nitrogen, the dominant component of Triton's atmosphere, builds up pressure and is released in magnificent plumes that erupt into the vacuum of space, a spectacle unseen on any other moon in our solar system. Deciphering Triton's true nature remains a tantalizing challenge, as its potential as an oceanic world harboring hidden seas beneath its icy shell sparks the imaginations of scientists and space enthusiasts alike. However, confirming this hypothesis requires further exploration and observation, tasks made all the more daunting by Triton's remote location and the technical challenges of space exploration. Neptune remains a mystery to astronomers, with questions about its inner composition and the mechanisms behind the formation of ice giants. Scientists are eager to explore Neptune's depths and unlock its secrets, hoping to uncover clues about the origins and evolution of these distant worlds. Future scientific expeditions hold the promise of unraveling the intricate chemistry and dynamics of ice giants, shedding light on their role in the universe. These missions will deepen our understanding of Neptune and provide insights into broader processes shaping planetary systems. NASA's James Webb Space Telescope, JWST, was launched to unveil distant worlds and explore the origin of the universe. This equipment is a monumental extension of NASA's previous missions, and the excitement of understanding cosmic mysteries is an epic adventure. We are still curious about the Big Bang and the formation of our solar system, and we strive to find definitive answers to the possibility of alien life outside our home planet. The new information gathered through the James Webb Telescope could lead to a new field of study in the solar system. The New Horizons mission has revolutionized NASA's efforts and expanded our understanding of Pluto, a dwarf planet. Before the mission, our knowledge of Pluto's surface was limited, with only a few detailed images taken by the Hubble Space Telescope in 2002. The James Webb Space Telescope then appeared on the scene, taking stunning pictures of Pluto's surface, craters, plains, and mountain peaks. These pictures not only fascinated scientists but also captured the imagination of many people around the globe, sparking a new wave of curiosity and passion for the unknown regions beyond our planetary neighborhood. In July 2015, the New Horizons mission accomplished its primary goal by flying past Pluto and its many moons, sending back the first detailed pictures of the celestial body to Earth. This moment in history has turned out to be an important step forward in space exploration. NASA set its sights on planets situated between Neptune's orbit and nearly 50 astronomical units, AU, from the Sun. The single most striking event of the mission was the close flyby of Pluto and its biggest moon, Charon. Additionally, New Horizons captured clear images of Pluto's 4 other moons, Nix, Hydra, Cerberus, and Styx. After data collection took 15 months, by October 25, 2016, the spacecraft had successfully collected 6.25 gigabytes of valuable information. It became clear that Pluto was subjected to dramatic surface and atmospheric variations, which contradicted the initial expectations. Despite its reclassification as a dwarf planet, Pluto displayed a dynamic nature evolving at a rate that prompted NASA to reassess and revise existing knowledge about this intriguing celestial body. One striking feature of Pluto is its heart-shaped region, the Sputnik planitia, which plays a major role in shaping many of its surface features. This geological phenomenon, scientifically termed the Sputnik planitia, is responsible for a process called true polar wander, which causes the planet's spin axis to shift. The alignment of Pluto's heart-shaped basin with a tidal axis between Pluto and Charon suggests that the heart's presence has an influence on the planet's orientation. Recent technological advancements have allowed scientists to delve deeper into Pluto's mysteries, leading to groundbreaking discoveries that overturn previous scientific assumptions about the planet's structure and origins. The existence of an ocean as one of Pluto's internal features radically alters our view of this distant moon, placing it among other oceanic moons in the solar system, like Titan, Enceladus, and Europa. Although there is currently no evidence that life could exist in Pluto's ocean, the discovery provides grounds for consideration of life beyond Earth and heightens the stakes for studying and finding oceanic worlds in our solar system. Another relevant discovery through NASA's Cassini mission was an ocean rich in phosphorus detected below the icy surface of Enceladus, a satellite orbiting Saturn. This finding ignited continuous discussions about the possibility of extraterrestrial life, as phosphorus is vital for the formation of DNA and RNA, the molecular basis of life. Pluto's case is unique, as its imaging equipment is not equipped to probe into its habitability, making it impossible to determine the exact chemical composition of its subsurface water. NASA continues to invest in exploring icy worlds like Pluto, but currently, the equipment for estimating the nutrients of its oceans is non-existent. However, studying Pluto offers insights into various aspects of planetary science, including understanding its geological features, origins, and evolution. One of the most surprising discoveries is a lake nestled within a mountain range just west of Pluto's iconic heart, measuring approximately 20 miles wide. Clues scattered across the surface hint at its past existence as a flowing lake brimming with a mysterious substance. The lake's existence on Pluto is even more astonishing due to its extreme cold temperatures of up to -230 degrees Celsius or -382 degrees Fahrenheit. The ability of liquid nitrogen to cool and flow on a distant planet is attributed to Pluto's fluctuating surface temperatures and pressures. As the dwarf planet orbits closer to the Sun, its surface undergoes subtle warming, causing nitrogen ice to transition from solid to gas under specific conditions. This transition may also lead to the formation of liquid nitrogen, giving rise to these unexpected features. Pluto's hazy atmosphere is incredibly thin, about 880,000 times thinner than Earth's atmosphere. It is believed to form when sunlight vaporizes its surface ice, leading to a reaction with methane and other molecules, producing a complex mix of hydrocarbons and resulting in a smog-like haze. These haze particles scatter blue light and settle down through the atmosphere, forming intricate horizontal layers that extend to altitudes of over 120 miles, 200 kilometers. As Pluto gets farther from the Sun every 248 years, its atmosphere continues to freeze, causing snowfall that sticks to the planet's surface. The specific nature of these snow particles remains a mystery, but scientists have observed a layer of nitrogen snow that condensed from the atmosphere and settled on the surface in regions like Tombaugh Regio. Pluto's mountains are composed of water ice frozen as hard as granite and covered in frozen methane snow. These towering peak formations can reach heights of up to 2.2 million feet, 3.5 kilometers, above the surrounding terrain. On the other hand, the mountains on Pluto show no evidence of tectonic or volcanic activities, suggesting that they are formed through sublimation erosion. This process occurs when frozen materials like nitrogen or methane on Pluto's surface are exposed to sunlight and transformed directly into gas, leading to the erosion of the surrounding terrain and leaving behind tall, spiky peaks. Pluto also appears to regenerate its surface in some regions, with evidence suggesting that a cold, slushy, lava-like substance has flowed over its landscape at various times. This unusual phenomenon, called cryovolcanism, involves the eruption of icy volatiles such as water, methane, and ammonia instead of lava. The presence of mountainous regions with pits or depressions on their surfaces points to the cryovolcanic activity of Pluto. Pluto's surface features include extensive fields of dunes resembling those found in deserts on Earth, stretching across its heart-shaped region. These dunes are similar to those found on Earth but exhibit unique characteristics. They may have formed not only from wind action but also from the melting of nitrogen ice, causing sand-sized methane ice grains to be lifted by rising gases and then carried away. Once airborne, Pluto's landscape also contains iceberg-like structures scattered across its heart-shaped region. These structures appear to be fragments of ice that have broken away from larger formations and seem to float across the frozen surface below. Scientists believe that these icebergs consist of frozen water since water ice is less dense than nitrogen ice. Pluto's designation as a dormant planet is becoming a relic of the past, as NASA unveils detailed images of sophisticated geological features on its surface. With each new discovery, scientists inch closer to understanding the complexities of celestial bodies like Pluto and uncovering the secrets they hold.